Don't forget to subscribe and share. Thank you.
All right, thank you so much for joining us again. And in this video, we are going to look at inverse function theorem. So we are going to use the inverse function theorem to take derivative. So this is the formula that we are going to use, and these are the steps. So we are saying that looking at the formula here, we need we need gene inverse, right? And when you get the gene inverse, we need to take the derivative of the gene inverse, and then we plug in gene of x. Gene of x will be always given, right? So find gene inverse, take the derivative of the inverse of the function, and then when we are done, we just plug in this inside the gene inverse. We simplify it and we just put it under what is here. So it's very simple. So that's the reason why we started by learning how to find inverse of a function, right? So now let me just go through the proof for this. So now we know that because this and this are inverse, right? So gene and this are inverse of each other. So their composite is going to be identical. What I mean is, now when I have gene of x of gene inverse of x, this is going to give us x. Yes, so this is one of the theorem that we are going to use. So we can use this one to prove the formula that we have here. So let's go through the proof before we take some practical examples. And don't forget, I'm going to give you example to solve at the end of the video for you to also, try your hands on. So what I'm going to do here is I'm going to now differentiate both sides with respect to x using the change rule. So let's do that. Differentiate both sides. So I'm differentiating with respect to x of gene inverse of x, and then this is equal to d over dx of x. So what are we going to get? Now, don't forget here we are going to use the change rule. So what does the change rule says? So if you want to also learn how to take derivatives, I have videos on derivatives in the playlist. You just go there and you find a playlist called the derivative playlist, and you can learn how to take derivative of different functions. So you can just check it. I'll leave the link to in the description, and you can just click on it to check it out if you want to learn how to take derivative. Okay, let's continue. So I'm taking the derivative of this using the change rule. So the change rule says that if I have f of gene of x, this is f prime, so I take the derivative of what is outside, and then I'll keep what is inside. So I didn't touch the gene of x. Then now I multiply it by taking the derivative of what is inside, which is going to be gene prime of x. So that is what we are going to use for this. So what is outside is g, and what is inside is g inverse. So this is going to give us g prime of gene inverse of x times, then we take the derivative of what is inside, what is gene inverse. So this is going to give us gene inverse of x or prime. And this is equal to, when I take the derivative of x with respect to x, we are going to have 1. So now what are we looking for? Now let's go and check what we are looking for. So looking at the formula here, we need g prime of x. So now let's try our hands on this and see if we can find g prime of x. So now let's see what is going to happen here. So since we need g prime of x, we are going to have g prime of gene inverse of x to be equal to, so what I'm doing here is I'm just going to divide both sides by this inverse of x prime, right? So I just divide it by this one too. So this is going to give us 1 divided by gene inverse of x or prime. Great. So now what can we do here? Since we need g prime of x, then we need to ask ourselves question, what is gene inverse of x? So that's basically what we just need here. So we are going to now do this here. Very, very simple here. So this is basically what is going to happen. I'm going to replace this by x. I'm going to replace this one by x. And then when we replace this one by x, what are we going to get here? So I think, okay, let me do this one rather. Let me make this guy rather the subject so that it gives us what we want. So let me just make this one rather subject so that I have 1 divided by gen prime, because I think we have 2 functions added down there. Great. Good. So if I do this here, then now what I want to do is I want to now set this one to gen of x. So when I set I'm going to set gen inverse of x to gen of x. So when I do that, I'm going to have gen of x prime, which is equal to 1 divided by. So remember, we are interchanging the function. Now my gen of x is my gen inverse, and my gen inverse is my gen of x. So this is going to give us, I don't like the way we are using the same functions, but I think that's how it's supposed to be. So this is going to be gen inverse of x prime of gen of x. So this is what you are going to get from the proof. Let me just go through quick. I think I didn't get it. So we are saying that this and this, when we put them in together, like finding the composite, we are going to have x, and then we took the derivative with respect to x on both sides. So we use the change rule to have what is here. Then we divided through by this, and we had this. So here, because we're using the same functions, it means that here, gen inverse here, this gen inverse here, is the same as gen of x. So I replace gen inverse by gen of x, right? And I will say that gen of x is also equal to gen inverse of x. So that is what we are doing. We are just trying to do the interchange here. So when I replace this one by gen of x, I'm just going to have gen of x prime, which is this. Then I'm just changing the gen of x to gen inverse, which is this. And I'm changing the gen inverse to gen of x, which is also this. So this is what we are going to get for the formula. Right, so let's take examples using the formula to just work it out. So let's look at the formula that we are going to use. So this is what you are going to use. So let's just write it down. So we are going to use gen prime of x should be equal to 1 divided by gen inverse prime of gen of x. So when you look at the procedure, first we need gen inverse, because gen of x is already given, which is here. So we need gen inverse, then we take the derivative of the gen inverse, and then we just come and do substitution. Now, another way of doing this is you can take the derivative direct, right? But let's assume that this is subjective written exams, and they are asking you to use the inverse function theorem. Then you don't have any options. You need to use this formula that we have here. But if it is a multiple choice and the question is saying that using the inverse function theorem, then you need to be smart. Because it's a multiple choice, we don't care about the process, how you are going to get the solution or the answer. You can just use let me say quotient rule to just differentiate this and get the results, and you are done. So that is one thing that you need to remember here. So when you are doing multiple choice and the question asks you to use the inverse function choice, you can decide not to use it and just go through the normal derivative and get your answer from the options. So now let's assume that this is a written solution. So we need to use this formula right here. So first we need inverse, which we've learned it. So let's go through this one quick. Let y equals to gen of x. So we are going to have y equals 1 divided by x plus 2. And remember, we need to interchange x and y. So x is equal to 1 divided by y plus 2. This is divided by 1. So 1 times 1 and x times this. So it's going to be x, y plus 2 equals to 1. and then xy plus 2x is equal to 1. We want to make y the subject, so we can have xy equals 1 minus 2x. And then we are making y the subject, so y will be equal to 1 minus 2x divided by x. So this is our gene inverse. This is our gene inverse, 1 minus 2x divided by x. But looking at the formula, we have gene inverse now, but we need gene inverse prime. So it means that now we need to take derivative of this. So let's go to taking derivative of this function here. So taking derivative of gene inverse, this we need to use the quotient rule. So let's go to the quotient rule quick. This is going to be u divided by v, right? So my u is equal to 1 minus 2x, which is the one on the top here, and my v is the one here. So I'm going to have v equals to x. So quotient rule, we need u prime, which is going to give us minus 2. So when you take derivative of 1 is 0, and minus 2x is going to give us minus 2, and v prime, when I differentiate x with respect to x, I get 1. So now what is gene inverse prime? Great. Now this is the quotient rule. So what is the quotient rule? We said maintain v, differentiate u, minus now maintain u and differentiate v divided by v squared. So don't forget the formula. So if you know this, we just do substitution from what we had here. So let's do that. V is x, u prime is minus 2, minus u is 1 minus 2x, v prime is 1, divided by v squared. Let's simplify that. We are going to have minus 2x minus, so the top, when I multiply 2 by 1, I have 1 minus 2x divided by x squared. Simplify again, and we are going to have minus 2x minus 1 plus 2x divided by x squared, and this is going to be minus 1 divided by x squared. Great. Now, if you know how to take derivative, you can jump some of the steps, right? So as your, someone who is guiding you to learn mathematics, I don't want to jump steps to get confused. I know some of you are very good with this, but I just want to do step by step so that those who are also starting from the scratch will really understand and appreciate what I'm doing here. So that's the reason why I go step by step. So I hope you are enjoying it, and give me like and comment too as well. All right. So now that we have gene inverse prime, now let me go and put it here. Let's just come here. Now we have gotten gene inverse of x prime to be equal to minus what do we get? Minus 1 over x squared. Great. Nice. So looking at the denominator here, we just need to make sure that we plug in the x by gene of x. So that's what we just need. So now gene prime, so let me write this one this way so that you see how the function is going. So this is like gene inverse prime of x. Great. So that you will see, you appreciate what is happening here. So let me also write this one again well. So gene inverse prime of x. Great. So now when you look at this one here, we have the inverse here, we have the prime here, but here is gene of x, but here is x. So we need to substitute the x by gene of x, so that now we can have gene inverse prime of gene of x. So what is happening here? Let's see what is happening here. Let's see what is happening here. So here, what is happening here is we are changing the x now to gene of x. So I'm going to replace the x by gene of x. So this is what is going to happen. This is what I tell my students. Make sure after you have gotten this, for you to do the substitution, sometimes because this x is in parentheses, for you to avoid mistakes, which I know some of you know how to do it, you can decide to, since this x is in parentheses, put the x in parentheses, just the x, to have x squared. So that now, if I'm replacing this x by gene of x, I just replace what is inside the parentheses by this, and what is inside the parentheses by this. So this is going to be just minus 1 divided by gene of x in parentheses squared. So you see that what is inside the parentheses here is x, this is x, and what is here is gene of x, and what is here is gen of x. But the question is, what is gen of x? Okay, gen of x is given to us as this: 1 divided by x plus 2. So now let's do the substitution there. This is going to be minus 1 divided by 1 over x plus 2 all squared. I hope you are not lost. I hope you are still on track. Okay, great. Now let's look at what is going to happen here. Now I can write this one as 1 divided by. Now let me just change my division sign very well. Make it blue so that you really understand what is going on here. Let me try and pick this guy and bring it here. So this is going to be divided by 1 squared. 1 squared is still 1, and x plus 2 squared is going to give us x plus 2 squared. So this is going to be 1 divided by x plus 2 all squared. So you see the way I've done this division? This is the original division. This is one function together. So now I can change this one to minus 1, and my division, I can write it this way: divided by, and then I'm going to have 1 divided by x plus 2 all squared. Now I hope you are not, getting angry because I'm going step by step. All right, so let's see what we are going to get from here. I think I can erase this one so that I have some space there. Great. So this is going to be minus 1. Now I change my division to multiplication, and I'm going to reciprocate this to have x plus 2 divided by 1. And then when I multiply this, I'm going to have minus x plus 2 squared. Great. So this is what we are going to get for this. And this that we have here is right here at the denominator. So our gen prime is going to be 1 divided by what the results that we had here. So therefore, gen prime of x is equal to 1 divided by our results, which is minus x plus 2 squared. Or I can say that minus divided by x plus 2 all squared. Great. So how can I confirm this? I can confirm that I can confirm this by just differentiating this function here using the quotient rule. So let me just go through quick, so that you will know how to do the confirmation, right? So let's just confirm the solution that we have here. Great. So we're using the quotient rule that we just learned. U v. So u prime is 1. Oops. U is 1. U prime will be 0. And v will be x plus 2. And v prime will be equal to 1. So let's just do g prime of x is u is v u prime minus u v prime divided by v squared. So this is going to give us v is x plus 2, but v prime is 0 minus, let me shift this one here. I can even bring this one here. Great. Minus u is 1 times v prime is 1 divided by v squared, which is x plus 2 all squared. This is 0. So this is going to give us minus 1 divided by x plus 2 all squared. And this is exactly what we had here using the inverse function theorem. So as I said, if it is multiple choice, you can just use the quotient rule to get the results. Simple. But if it is a written exam and the question is saying that using the inverse function theorem, then you don't have any option but to use the inverse function theorem. When you are done and you have time, you can just use this to confirm your results to see if you are not making mistakes. Right. Now let's look at the next question. I love the next question. It's very nice. Now we have the len function and we want to, work with this one. So now how do we find the inverse of this? Now let me write my formula down right. So we have gen prime of x to be equal to 1 divided by gen inverse prime of gen of x. So here we can say that we are going to let gen of x to be equal to the natural log of 5x minus 3. So because of that, we have our gen of x already. So we need f inverse and then we need f inverse prime. So let's go through by finding, gene inverse. Y is equal to the natural log of 5x minus 3. So how do we find inverse of this? Okay, great. Now, we don't need to do any simplification. First, we just need to interchange x and y. So we are going to have x equals the natural log of y, 5y minus 3. Now let's make y the subject. Now remember, when we started the inverse, anytime we have anytime we have the log function, we look at the base and we use it, right? But when we have the natural log, the natural log always goes with the exponential function. So we know that e of this is equal to 1, and we also know that e to the power this is also equal to 1, right? So because of that, anytime we have the natural log, for us to get rid of, we need to take the exponential function. So here I'm going to take the exponential function on both sides to have something like this. Great. So this is what I'm going to get, right? So now this, because I have this one here, no, okay, this one rather. So you see that if natural log of 1, this is going to give us the 1 here. So it means that this is just going to give us what is inside the parenthesis here. So this is going to be e to the power x, which is equal to 5y minus 3. Making y the subject, move minus 3 to the left and have this equals to 5y, and our y will be equal to x, e to the power x plus 3 divided by 5. So this will be our gene inverse. I hope you understood the process, right? If you don't understand anything, you can still give your comments, you can still leave your comment, what you don't understand in the comment section, and we will help you to find out the functions. Right. So now let's do this one very quick and see what we are going to get from here. Now that we have the inverse, now let's take the derivative. Right. Let's take the derivative of this. This is going to be amazing. Now, this one we don't need to use a quotient rule if you can see this. This is the same as 1 divided by 5 times e to the power x plus 3. So this is constant, right? So we can just ignore it and just take the derivative. So f inverse prime of x will be equal to 1 over 5, but we just need to take the derivative of what is inside the parenthesis, right? But we know that taking derivative of an exponential function, let me say u is just u prime times this. So when you compare this to this, our u is just x, and we know that x prime is just 1. So it means that when I differentiate ex, we are just going to have this. And when I differentiate a constant, I get 0. So this is what we are going to get at the end of the day. So this is just e to the power x divided by 5. Wow. Wow. Okay. So now that we have gene inverse and gene inverse prime, let's go back to our formula, right? So now we know that gene inverse prime of x is equal to e to the power x divided by 5. So what am I going to do? I'm just going to make sure that my x is in parentheses to avoid mistakes, right? So I just say that, okay, ex. You can decide not to do it in this way if you know how to do it, but I'm doing it for those who are confused doing substitution. So now let's look at what we can do here. Now I need gene inverse prime of gene of x from this side. So I'm just going to change the one in the parentheses to gene of x. So this is going to give us equals e to the power gene of x divided by 5. And what is gene of x? Gene of s is this right here, right? So let's just do substitution, and something nice and interesting is coming to happen. Okay, so let me just bring this one here. So I have this, and I'm going to have the natural log of 5x minus 3 divided by 5. Now look at what happens here. We said that if I have e to the power ln of 1, I have the 1. So what is inside the parenthesis here is what is here, which means that this here is just going to give us what is here, and this is going to give us something amazing here. So we are going to have 5x minus 3 divided by 5. And guess what is going to happen? So now that we have gotten what is here, we just need to put this one at the denominator of gen prime, and then we are done. So I'll just write my final solution here. So now my gen prime of x, so gen prime of x is going to be 1 divided by what we have here, this one divided by this. Let me change the color of this so that you will see what is going to happen here. So make this one blue and have my 5x minus 3 divided by 5. So as you know, I can just do this one straight. So 1 divided by this will reciprocate it, and I'm going to have this one as 5 over 5x minus 3, as we did for the first video. So this is what we are going to get for our g prime, and I would advise you to try and take the derivative of this using the chain rule, and you see that we are going to get the same results that we had here. It's very simple. So let's do it. I think it's just 2 steps and then we are done. So we know that if I want to take the derivative of x of the natural log of u, this is 1 divided by u times u prime, right? So what did I do here? It's just very simple. It's just 1 divided by what is inside the parenthesis times the derivative of what is inside the parenthesis. So let's do the same here. Now, y prime will be equal to 1 over what is inside the parenthesis, which is 5x minus 3 here. Then I need to take the derivative of what is inside the parenthesis, which is going to give us times 5. So when I multiply it by 1, and then I get the 5 here, and this is the same as what we had here. So you see that this was very 2 lines to get it done, but we need to use a whole lot to get this. So don't forget the strategy. When it is a multiple choice, you just go by, the process of, just differentiating it straight using your knowledge of the differentiation. But if it is written, then you need to go through the process. Okay, let's take question 3. Interesting with y to the power. This is x cubic root. So let's go through the process. I love writing down my formula first so that I know exactly what I'm looking for. So gen prime, gen inverse prime of gen of x. So one thing about mathematics is about practice. You practice with more questions and you become very fast and you become very good with solving, right? So you see that I've written the formula like 3 times. Anytime I'm solving, I write it down. So there's no way I'm going to forget this formula right here. So now let's look at this. Now first, because the function is f, now I can change this one to f, and then I can change this one to f, and I can change this one to also f, so that I make it suit the function that I have. So I'm going to let y equals to cubic root of 2x plus 7. And then what is going to happen here? Now let's just make y the subject. So I interchange x and y and have 2y plus 7. But cubic root is the same as 1/3, right? Great. Now, because I want to make y the subject, I need to get rid of this. How can I get rid of this? So 1/3, if I multiply this one by 3, of course, I can cancel this one and 1/3 will go. So I will decide to, multiply this one by 3. And I need to do the same for the left by multiply this one 2 by 3, because this is to the power 1. So I need to multiply this one 2 by 3, right? So that I can get this one done, right? So multiply this one by 3, multiply this one by 3. So this is going to give us x to the power 3, 2y plus 7. Then now I can make y the subject. So x to the power 3 plus minus 7 equals 2y, and my y is going to be x to the power 3 minus 7, all divided by 2. So this will be my f inverse of x cubed minus 7 divided by 2. And the more you solve examples to you become very fluent with the procedures, right? How to go through the process. So you know that after this one, I need this. So after f inverse, we need f prime, right? So let's look for f prime. Now I can write this one as 1 divided by 2 x to the power 3 minus 7, because 1 over 2 is constant, so that it will help me to find my f prime of x. So this is going to give us 1 over 2, and I just deal with what is inside the parentheses. Use the power rule and have 3x squared, and when I differentiate a constant, I get 0. So finally we are going to have 3 over 2x squared. Beautiful. Now let's go back to our formula here. Let's go back to our formula here. Great. So now we have f inverse prime of x to be equal to 3 over 2 x squared. So as I said, I'm trying to put my x in parentheses so that my substitution will be very easy for me. So now let's go through. I need f prime, f inverse prime of f of x from the denominator here. So now this is going to give us 3 over 2 f of x squared. So I just changed my x to f of x and my x to f of x. Now what is f of x? F of x is right here, which is here. So now I can just do the substitution there to have 3 over 2 cubic root of 2x plus 7 to the power 2. Nice. Now what can we do here? So I'm going to do something beautiful here. It's very nice. This is the same as 3 over 2. This is 2x plus 7 to the power 1 over 3 squared. So it means that this is the same as 3, and this is 2x plus 7 to the power 2 over 3. This is true. This is true. So we're almost done. We just need to place this one at the denominator of f prime. So this is just going to give us f prime of x to be equal to 1 divided by 2 over 3 2x plus 7. Great. And this is also the same as 2 divided by 3 2x 7 2 over 3. And those that they like doing more simplification, this is also the same as 2 divided by 3 cubic root of 2x plus 7 squared. This is also true. Great. So this is the derivative, and you can just try to take derivative of this. You can do it and confirm if we got the same result. So you can do that one to check it out. So this is the end of the video, and I'm going to leave this one for you to also try. Please try it and leave your answer in the comment section. And as I said, you can also leave your answer, you can take a picture of your solution and post it in the Merbs Connect YouTube community for us to check your solution for you, because sometimes when you write your solution up and we see it, we can see maybe if you had some mistake somewhere, and we can also correct you as well. So see you in the next video.